This video has three parts. First, we solve this problem related to powers and also useful for this problem of USACO, similar. Because here we should check something to the power of something. And it's good to have to solve a problem related to powers before that. This math problem in part 1. In part 2, we will solve this USACO problem, first problem of December 2023, first contest, bronze part. And in part 3, I leave homework. You can use the time codes, the chapters in this video to go straight forward to the part that you want. We will consider important ideas that are useful for 2024 and so on. We will consider background ideas. If you want to learn important background ideas that are useful for USACO, AMI, USAMO, IMO, AMC, want to learn 40, 50 important ideas in each topic, feel free to send message to my WhatsApp number in the description. The important ideas in number theory, geometry, combinatorics, algebra, and algorithm. If you want to learn them, as I said, send message to my WhatsApp number. Okay, for this problem, we want to see which one is larger, 100 to the power of 100 or 99 to the power of 101. So, for this one, we divide both sides by right-hand side. So, it will be what? 100 to the power of 100 over 99 to the power of 101 and 1. We should see which one is greater. So, let's focus on left-hand side. I write 100 to the 100 over 99 to the 101. Now we can say it is equal to 100 to the power of 100 times 99 to the power of 100 times 1 over 99. Okay, so now the powers are equal. We can write as 100 over 99 to the power of 100 times 1 over 99. Now, I can write 100 as 99 plus 1 over 99 to the power of 100 times 1 over 99. In next step, we can divide. 99 over 99 is 1 plus 1 over 99 to the power of 100 times 1 over 99. Now, this part, 1 over 99, I can draw x plus 1, suppose x plus 1 over 1 plus, let me correct it, and let's consider this one as ID of 1. If you have x or 1 plus 1 over x to the power of x, suppose x is positive. Okay, let me tell you the graph is what? The graph near 0, it will be 1, and it will be something like this. Okay, it approaches to what e? E is 2.7 something. Okay, so as you can see, it's always less than E, or we can say less than 3. So this one is 1 plus 1 over 99 to the power of 100, but here it is xx, 99, 100. So we should change 100 to 99. I can say it is equal to 1 plus 1 over 9, 99 to the power of 99 times 1 plus 1 over 99 times 1 over 99 because of this. Now we want to prove that it is less than 1. How we can prove this? Okay, so this one by idea 1 is less than 3. 3 times this one is 100 over 99 times 1 over 99. So it will be what? 300 over 99. If you calculate, obviously it is less than 1. But let me say, for example, we can say 300. Now let's decrease the denominator. We can write 90 squared. So because the denominator here is smaller, the whole fraction will be greater. And this one equals what? 300 over 81, 0. And you can cancel these two zeros. It will be 1 over 27. And it's less than 1, a rigorous proof. So this one is less than 1. We can conclude 1 over 100 to the 100 is also less than this number. Okay. If you want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description if you want to learn background ideas. Now let's try this USACO problem. So first, read this problem and pause the video and read this one on your own. Now let's consider this input output. In this input output, n number of cows is 3, number of candy canes is 2, and the heights of cows are 3, 2, 5, and height of candy canes will be 6, 1. So let me explain for you. It says we consider first candy cane, we hang out like this, and for example, it will be what? It will be, for example, the height will be 6. Okay. Now we consider cows one by one, 3. Height 3 goes and take this part. Okay, so this height is 3 and we have 1 plus 3 because of this part. So let's move it here. In next step, now this one will be removed. This one with height 2 comes. Then when it goes, we don't have anything, so 2 will be 2 again. And the last part with height 5, it goes. And because the height here is 3, with height 5, it goes and remove what? This part. So this 5 goes and it will be plus what? 3 was for this one, it's plus 2. Okay. Now for second time, the heights are what? 3 plus 3, 6. 2 and 5 plus 2, 7. It's for second. Okay, let's remove them. Now let's consider second candy. 1. So for this one, first one, it's completely because it is 6. And then it will be 6 plus 1 because of this. And then for others, we don't have anything. So 6 will be 7 and 2 and 7. So it will be this. Now, let's see how we can solve this problem. So we have n cows. If we consider n cows, m candy canes, and heights of the cows and cows h1 h2 hn, we show it like this. For candy canes we consider the heights are c1 c2 to cn. Okay, now let me tell you something. If first one, for example h1, like our example here, when this one was 1, this one was 6, for second time when first one was 6 and the candy cane was 1, first cow it's all of this candy cane, the whole amount. So we don't have anything and we don't need to continue. So we can consider something. In each step, we will update h1 in each step. If h1 is greater than ci, so first cow completely, it's this one, h1 will be h1 plus ci, and other things won't change, h2 to hn. Okay, so for this case, we can apply this by order of 1. Okay. Now let's consider the case that h1, here we can say also h1 greater than equals c1. If h1 is less than ci in a step, then what happens? h1 will be what? Here, in this part, ci was something like this. In this one, h1, for example, is this one, and ci will be this one. So hi will be what? Will be h1 plus h1. So it will be 2h1. Now in this case, I will check all cases. I want to check all cases. I say, okay, this is this, and you can search. You can say, okay, h1 will be what? This height we consider from here. So, okay, for example, we can say, okay, this part, for example, a starting point was what? Always starting point was, for example, from 1 to end point, or we can only consider this one. So First, the starting point is 1. Then if it is, for example, 1 base. Then in next part, when h1 is that, st will be what? h1 plus 1. And you will update st each time. For example, when h2 comes, what happens for h2? We check if a starting point is here less than or equal h2, if starting point is less than or equal h2, then h2 is. Okay, so h2 will be what? Will be h2 plus this part, for example, if it is this. It is what? And maybe what we have two things. Maybe, for example, it is something like this. It is h2, it is the candy cane. Maybe we have something like this, h2, and it will be something like this. Okay, so here we should write two things. If Ci is less than, here is Ci, this part is Ci. We can say what? If St less than or equal H2, we know that second cow is some part. So we can say if Ci is less than or equal H2, cow number 2 is completely the rest. So H2 will be Ci minus this pointer is Ci, this pointer is St. Ci minus St, this pointer is Ci. Ci minus St plus 1 plus H2. Okay? And else we have what? Ci is greater than that. So, sorry. For this part, it's completely this one. This one is Ci, this one is St, and it's completely for this one. It's from H2 to from St to H2. So H2 will be H2 minus St plus 1 plus H2. Okay, we have these things. And then after that, you should update also St. How can we update St? Here, this one, it's this one completely. It is for case 1, case 2. Case 1 is this one, case 2 is this one. So for case 1, we should consider we should work on next candy. For this one, we should update St. St will be what? H2 plus 1. Because we don't have from here, all of them will be eaten. This one, H2 plus 1. Okay, and you continue until all the whole candies will be eaten, or we consider all cows. Like exactly H2, you can have a 4. On H3, H4, all of them, we can say 4. And instead of H2, you write, for example, HJ. Okay? Now we considered all these things. So, the order of this part is what? You check these things, order of 1 for each cow, so it will be order of n. Okay? Now for this one, for calculating order, I consider m and n equal because the range are equal. For calculating that, is it good for with respect to our time? M and n are from 1 to 2 times 10 to the 5. N and m are from 1 to 2 times 10 to the 5. So what happens here? We check these things. Order of n here. So I should see how many times do we have. Let me write with pink. This case 1, case 2. How many times do we have case 1? How many times do we have case 2? In case 2, each time h1 will be doubled. Okay, so for case 2, if we want to consider how many times do we have case 2, it will be what? So the height of h1, they are at least what? It says from 1 to 10 to the 9. From the range From 1 to 10 to the 9, from 1 to 10 to the 9. Okay. So when h1 is doubled means h1 is what less than ci. So h1 at first is at least 1, then in next step if it's doubled 2, 4, 2, for example, 1024 is 2 to the 10. Okay, so 2 to the 10 is less than 1000. So we can say 2 to the 30 is greater than 1000 to the 3, so it will be 10 to the 9. So after 30th step, we reach to a number that this one, if we reach this part, it is 2 to the 30. For example, suppose h1 is 2 to the 30. If it wants to be doubled, h1 should be less than ci. h1 is greater than 10 to the 9. It should be less than ci, but that's a contradiction because from assumption of the problem, ci is at most 10 to the 9. So we have at most 1 to 30 steps, this one. Okay, so it will be order of 30n, okay, constant, or we can say order of n. Plus what? This one will be, the order of this part is 1, it is at most n steps. So as you can see, the number of calculation is around at most, in the worst case, 31 to the times n, it will be 31 times 2 times 10 to the 5. Okay, so it will be around 2 times 31, 60. We can say less than 60, 110 to the 7. So the time would be okay. And we've considered this idea. Also, we could solve this problem with other ways. If you want to learn other important ideas, other background ideas, or other solutions, or want to solve other problems, as I said before, feel free to send message on WhatsApp number in the description. Let me tell you a similar problem as homework. Suppose m and n are integers, and suppose 2 to the m minus 2 to the n. It is equal to 480, and find m and n are what? And comment your answers right below this video. Okay, and if you had any question or wanted to learn other background ideas, as I said before, want to prepare for USAMO, USACO, AMC, AMI, and other rounds, feel free to send message, my WhatsApp number in the description. Okay, thanks for watching this video. Bye.